Hi, how's it going? In this video we're going to continue working with Vulkan and we're going to create our instance. Now, if you've done any work with Vulkan before, you'll be well aware that there is a really large amount of boilerplate which needs to be done in order to get something running, but I do think it's a beneficial exercise to go through that. To start with, poll results. So I had a few comments saying, hey, this is really cool, but can we try some different things? And I'm sorry to say that the majority of people don't want to try and use... No, I'm kidding. Okay, so as for the question of which windowing library we'll use, the majority of people voted for GLFW, 151 votes. That's, yep, GLFW. Now, I sort of partially agree with that for the reason that, firstly, GLFW handles mouse movement more smoothly, and secondly, GLFW has quite a minimal interface with Vulkan. All you pretty much do is say, hey, I'm making a GLFW window. It gives you a window. You can request no API at all, take full control. You've got it. Whereas with SDL, you have this like SDL Vulkan header. You have to run through these other things. I mean, ultimately, it's not that. It doesn't interfere that much, but yeah, we're going to go with GLFW. And then as for the question of Vulkan header versus C++ header, it was a slimmer majority for the C++ header and a lot of strongly opinionated sides either way. HPP and GLFW, that's what I'm going with. Okay, so to start with, I did not include Vulkan in the previous video, so I'm briefly going to talk about how I'm going to do this, or rather how I did it. Okay, so if we were to search for the Vulkan SDK, LunaG is pretty much the place that we can get it, and we can download any of these. I don't have the 100% latest version, but I've got something, so we'll just go with that. What we can do is we can download it. It has an installer. It installs somewhere on our hard disk. So in my case, I've got this, my local disk and then my Vulkan SDK folder as created by the installer. If I pop in there, I have a few things. I have lib, a lot of things here. The only thing I've used in this case is Vulkan 1 library file. It's the only file that I'm using. And then we have include, and in this case I'm using Vulkan, and for some reason it complained if I didn't have VK video, so I just included that as well, but we shouldn't need to. There should be a way to not include all of that. But yeah, basically physically copy pasting files. So if I were to pop in here to my project, the code, as always, is linked down below, and it's also split into sort of start points and finish points if you like to gamify your learning. If not, no worries, the finished stuff is there as well. But if we go into these dependencies, we can see we have these file folders, and then inside the folders we have the headers, and then I've also got a library folder which has all of the library files. But just for purposes of brevity and so that I'm not repeating myself, I've actually just not included this dependencies folder in the GitHub repo, with the understanding that it should be a trivial thing to set up. Okay, so here's the project. And before I get more into it, come on, how many little pop-up things do we need? Okay, so the only other thing I was going to mention about including Vulkan is we can totally do this, but we just need to, as I'm sure you would be familiar from other C++ projects, we need to set our directories. So if we go to our directories, we've got, for the include path, we've got the dependencies folder of the project, and then likewise for the libraries, it's dependencies lib. And then also, if we go to linker, input, I also need to specify exactly which library files I'm using. So I've got this GLFW3 library, Vulkan 1 library, and I am good to go. Okay, so I guess I'll briefly talk about the renderer or any changes that I've made to it in setting this up, because I want to keep the majority of the step-by-step code with me stuff. I want to constrain that to the Vulkan stuff. This engine stuff, I'll talk about it, but it's not going to be the main focus. So I've got my engine as before, I've got my constructor and all of this. Now I've added two things. First up, I've added a Vulkan instance, which will need to be created. And then secondly, I've added this queue, this double-ended queue. And the reason for this is that as we make more Vulkan objects, every Vulkan object will need to be created and destroyed. And it will need to be created and destroyed in a certain order. So what we could do is we could have a destructor function which steps through each of the destructors in order, and that'll basically work. But a slightly quote-unquote cleaner way to do it is to simply remember all of the destruction functions. So the way this works is if I go to my renderer, let's pretend that this make instance function has been created and it works. So what I do is when I create the instance, I pass along the deletion queue with that, and the creator will directly at that time push on, the deleter function, the destructor. And then when it comes time to destroy everything, run our collection, we simply pop through the queue and continually execute all of the functions to destroy the objects. Okay, so with that back end out of the way, the stuff that I'm really going to be focusing on today is the instance. So if we go to our source code and our renderer, I've made this instance header and source file. In the header, we have got this. It's pretty much the prototype for our make instance function. And note that I've defined that I'm not going to be using any exceptions in Vulkan because, as a few viewers have rightfully pointed out, exceptions incur extra overhead, which we simply don't need. So that's that. Now, if we go to our instance source file, this is pretty much the steps involved in making the instance, but I have strategically left some to-do items. So let's have a look through this. First up, pretty much we get our logger, send the message out, and then what I'm going to do is I'm going to query the system and say, hey, which version number can we support? And the way we can do that is, because I'm using the Vulkan HPP header, which for reference is included up here, Vulkan HPP. We can go into the Vulkan namespace. Here we go, and enumerate instance version. Now, this will complain because when we define that we don't want any exceptions, like if I were to remove this, it's a function, so we need to call it. But if I were to remove this, this would be perfectly fine. Okay, great. It returns an unsigned 32-bit integer. But if I were to have no exceptions, then every function now, instead of returning a regular value, returns what's called a result value, which is sort of like an optional. So what we can do is simply grab the value. I do not have any reason to believe that this function would throw an exception. I guess the only case is if our system really didn't have Vulkan implemented, but this one does, so I think that's fine. So we've got that. This is our version number, but our version number includes various components. So to see this in action, we can go to the loggers function here, report version number, and as you can see, this 32-bit unsigned integer holds various bits of information in it, which are extracted via these functions. And the way this works is pretty much described here. This is a screenshot from the documentation. The big thing I want to draw attention to is up here, the meaning of each of these things. So we have this thing called a variant, and the variant is basically which Vulkan version are we using? Not like that. I mean, are we using pure Vulkan version? Are we using some other implementation of the Vulkan API? In our case, it's just going to be 0. We have the major version, minor version, and so on. And yeah, as we can see in these dot points down below, these are packed together using various bit regions. So the next step is we need to specify some information about the application. As we can see here on the right from the C specification, not a lot of this is important. Maybe the most important field is the bottom field down there, API version. Now, the API version is specifying the maximum version for the API. What do I mean by that? Well, if we specify that we're going to be using Vulkan version 1.1, then we can't go ahead and start calling, 1.2 functionality, at least not without doing some checks and things. We can call, version 1.0 functionality and version 1.1, that's fine. All right, so let's go in and set our application info. We'll go to the renderer. Oh, whoops, not that. Instance. Okay, great. So we've got our version number. Now, actually, we don't need to zero out the patch number. It's actually completely ignored, but also it doesn't hurt. So this stuff here I've got is from the Vulkan structs header, and we're showing us some things. So what I'm going to do is I'm going to construct a Vulkan application info. We've got some things to put in. First up, we're going to put the application name that's actually given above. And then for the application version, I'm just going to put in the version number. That's fine. For the engine name, it's none. There's no engine. That's fine. And then, yeah, for the engine version, let's go ahead and put, it really doesn't matter. Just like that. The next thing we do is we're going to use glfw, but glfw is going to require that certain features are supported in order to work with Vulkan. So what I'm going to do is this glfw extensions is going to be a list of strings. And so we can get that using the glfw function. Yeah, get required instance extensions. And this will give us back a pointer, or it'll basically give us back that array of strings being all of the required extensions, and then it will also populate the extension count so that we know how many strings are on this array, if that makes sense. And this will probably fail right now, but at least I want to give it a go. So I'll click run. It'll fail because I haven't completed the creation stages. Maybe it'll succeed, I don't know. Okay, well, so far it's succeeded. All right, so as we can see here, we have extracted variant 0. We're using pure Vulkan 1.3. glfw is requesting the Vulkan Kronos surface extension and the Vulkan Kronos Win32 surface extension. And there we've got it. Okay, so strangely this did handle everything fine, but I'm just going to go through and deal with the instance create info. Okay, so as I said, in order to create an instance, we're going to need to pass in instance create info. Now, this C specification includes two fields which are always in there, but aren't in the Vulkan HPP header. That is the structure type, S type, and the next pointer. Or at least by default they're not in the, by default we don't need to specify them. So the two big concepts are really Vulkan layers and Vulkan extensions. So what a layer is when a Vulkan function is called, by default there is no error checking or anything. But the purpose of a layer is another function call that sits in between our program and the driver. and it intercepts that message and checks things and can report if we have bugs or if things aren't being done correctly. This introduces some overhead, of course, which is why Vulkan by default doesn't have error checking, but it's something that we can easily sort of switch on, switch off, and it's very useful when we get the hang of it. And then extensions. So we have our standard functionality, and with our standard functionality, that's very, very minimal. It's basically opt-in. So if we want to add extra things, we need to specify those extensions. In this case, for the window surface, we needed to specify that we were using a Win32 surface. Cool, so let's go ahead and set up our instance create info. Okay, so we'll get our Vulkan instance, whoops. This instance create flags will basically set sensible defaults for the flag values that we need. We're going to take a pointer to the application info that we defined above. And then we'll have enabled layer count is 0. We've got no layers at this point. Okay, so 0, nothing, and then our extensions. So our extension count, currently it's just the GLFW stuff. So we'll go extension count, and then for the pointer to the list of extensions, I'll put in GLFW extensions. Okay, so there we've set up our instance create info. We then use that to create an instance. And again, because we're using no exceptions, that will give us a result type. We can then check if that result was a success. If it's not a success, then say, hey, we failed, just like that. Now, if it is a success, then we can go ahead and grab the value. The value in this case will be the created instance. We can return that, but at the same time, I'm going to push on the deletion function. Now, what I've done here is I've taken this VK instance, which is, it's basically a class which wraps up the info that we need. But if I were to put this into the Lambda function down below, we would get a failure because the class would go out of scope and that value would be forgotten about. But in Vulkan, everything is just a 64-bit handle. So what we can really do is take that class, and then the constructor here, the copy constructor, will basically extract that 64-bit handle and put it in there. And it's okay, because handles, 64-bit unsigned integers, can be passed around by value without losing reference to the original thing, right? It's just a number. So this allows us to actually create the destruction function, the deletion function, independent of the scope. Right, so let's just step through this again. So we have our renderer. The renderer uses this function to create an instance, and that gives us back the instance, and it puts the instance's deletion function onto the deletion queue. And then when the engine wraps everything up, it straight up just deletes things in opposite order, so the newly created things are deleted first. There we have it. And as we can see here, we have everything good to go. And then when we delete this window, it says, hey, deleted instance, no errors. And we can verify this by going down here and saying, hey, destroy the instance. And now we are going to get an error. So just as a side note, I'm going to talk about custom memory allocators. When we went ahead and created this instance, there were a few things. If we were to sort of hover over here, And we have this allocator, which by default is a null pointer. So what we can do is we can create our own custom memory allocators, pass them in there, and then they will be used to allocate the memory for this instance. However, in this case, the instance object is not what I would call runtime allocated. That is, it's created once at the beginning of the program, it's deleted once at the end of the program. In our case, there's only ever one instance around, and so there's not really a performance benefit to using a custom memory allocator in this case. And additionally, when we go to destroy the instance, this null pointer on the end is the memory allocator. I'm using the C version in which we don't have default values, so I've explicitly said no allocator, that's why we have null pointer, and it just matches. Because I will be using VMA, Vulkan Memory Allocator, but I'll just be using that for device memory, so like buffers and things. Okay, so congrats! I've given up on being a normal person. I'm just putting, yeah. How good is Stellar Blade? Love that game. Okay, so congrats. We've got our instance created and things are not blowing up, hopefully. As our next step, we're going to be enabling validation layers and setting that up so that we can get error reporting in our program. I hope to see you there. All the best. Bye.